Hey guys, so I'm gonna break these videos into parts just because it would take very long and I don't want to re-record things just because if I said something wrong. Alright, so today some of the slides we didn't get to do, but also at the end of the lab there we had some review questions. So let's start with this. Arcsine of 1/2. Again, to think about arcsine, or just the inverse of any trig functions. Pretty much this is the same thing, okay? Arcsine of 1/2 is just asking us to find the value of the angle, okay? In other words, sine inverse of 1/2 is theta, or you could also think of it this way. Sine of an angle that gives us 1/2, okay? So we're trying to find that angle. So we got 5 options here. We know that sine of 0 is 0, and then sine of pi over 2 is 0, it's 1, and then sine pi is 0, and sine of 3 pi over 2 is -1, right? So none of those are helpful for us. Again, I would fill out my first quadrant here. It's just a good guide of the rest of the circle. Again, I would put all of them over 2, and then 1, 2, 3, 3, 3, 2, 1, and square root all of them on the numerator. Okay, and between these 3 angles, the pi over 3, pi over 4, and pi over 6, the y coordinate that has 1/2 would be pi over 6, right? So here we find theta. Theta is pi over 6, which means sine pi over 6 is 1/2. So this is your answer. Okay, it's that easy. All right. Okay. All right. Next one. So previously they asked you the angle if sine inverse is 1/2, right? Arccosine of 1/2, or again they would write it as cosine inverse of 1/2, is pretty much asking us what angle gives us the length of 1/2. Okay. So now again, going back to our unit circle, the only x-coordinate between these 3 that gives us 1/2 is pi over 3. So pi over 3 is your theta. Cosine of pi over 3 is 1/2. Okay? Alright. And technically, remember our discussion in class, it's also 5 pi over 3 because they both share the x-coordinate 1/2. So here, technically, this is saying that when theta is between 0 and 0 and pi over 2. Okay. This one here as well, 0 and pi over 2. So we're just looking at that first quadrant. Okay. Again, cosine inverse of 1/2 is pi over 3 or 5 pi over 3, and here sine inverse of 1/2, in other words the y coordinate with 1/2, is also 5 pi over 6. So technically it's also 5 pi over 6, and the multiples of it, right? Again, I would add the restriction. That's why it's only pi over 6 for this question. Okay. All right. So now we've done arc cosine and arcsine. Now let's do arc cotangent. Okay. Again, do not assume that it automatically pops up in my head what cotangent inverse of -1 is. I have to work it out as well. Okay. So again, we have to make sense of this, right? What does this mean? So it means that we need to find an angle. If we take the cotangent of this angle, it will equal to -1. Again, you have to think about what cotangent means. It means 1 over tangent theta, or you could think of it as cosine theta divided by sine theta, right? So we're trying to find an angle theta, that if we put their x coordinate divided by their y coordinate, it would give me -1. So I'm going to go back again to that unit circle. I would eliminate these angles just because there's no way that if I take x over y, okay, x divided by y, that would be undefined here. X divided by y, that would be 0. This would be undefined. This would also be 0. Okay? Excuse the background noise. And then I would also eliminate these because there's no way that if I divide x divided by y, it would give me something equals to 1 or -1, right? So we're left with the pi over 4s. Okay? Alright, so clue. I'm gonna put that clue for theta. It's a multiple of pi over 4. That's one of our clues. And another clue, it should be either the x or the y coordinate is negative, right? Because x over y, in order for you to get a negative result, either x is negative or y is negative, okay? So that brings us again to the unit circle. Where in the unit circle when you have either x or y is negative, okay? So we have the second quadrant and the fourth quadrant, right? And again, we knew that the clue was it's pi over 4, right? So we have 3 pi over 4 and 7 pi over 4. And again, the multiples of it, right? Like if we take another period, another cycle around the circle, again, the multiples of it. Okay, so it could be this or that. It would only be this if I restricted the theta between 0 and pi. It would only be this if I restricted it from pi to 2 pi. But again, I didn't restrict anything, so you could write this or that, and again, or the multiples of it. All right, that's about it. And stay tuned for the second part.